again back with a video. Just again with a miscellaneous question, which is question number 72 on Leetcode, which is factorial trailing zeros, which is a medium level question. Uh, so the question basically says is that we have a number and we have to calculate the factorial of it, and then we have to calculate the trailing zeros. Okay, let's see the example. If n is 3, then factorial is 6. So there are no trailing zeros. So there will be trailing number of zeros is 0. And then n equals to 5. We can see the factorial is 120. So the number of trailing zeros is 1. And 0, output is 0 because the factorial of 0 is 1. So there is no trailing zero. So there are two methods. The most common one is to calculate the factorial of the number and then simply counting the number of zeros, trailing zeros, which is absolutely fine. But the problem in that question is that if the factorial of a number like for 30 is a big number, which exceeds the range of int, so for that number, that method, I don't think that's appropriate to use, because we may have a very large number in test cases which can give a huge factorial. So for that number to save will can be a problem. So the other method is the which I'll be using here is the prime factor method. Uh, by prime factor, like we have to calculate the number of trailing zeros. So we have to calculate the number of tens uh, trailing of the factorial. So basically, what we have to do is we have to calculate the pairs of 5 and 2, because these are the only number which will be giving us the multiplication of 10. Okay. So if we take an example of 30, like we can see the 30 is 5 into 2 into 3, 28 is 2 into 2 into 7. So we have to calculate the number of 2's and 5's. 27 will not give any 2's or 5's. 26 will give us 2 into 13, 25, 5 into 5, 24 will give us 3 2's, 23 will not, 22, 2 into 11, 21 no, and 25 into 22. So, and that goes on. What we can see from this here is the number of 2 will always be greater than or equal to the number of 5's for every number. For factorial for every number, the number of 2's will be greater than or equal to 5. So if we calculate the number of 5's, so I think then we can say that we are done. By calculating the number of 5's in the factorial, then that will be the number of leading zeros, sorry, trailing zeros in that factorial, like here. But there is a slight problem. Like for 25, we have two 5's. For 125, it will be 5 into 5 into 5. For 625, it will be 4 5's. So we have to take care of that situation. So for that, what we are gonna do is first let's take a variable which will be saving our count 0, and I, which will be using the loop. We're gonna do is while and divide by I is greater than equals to 1, count plus equals to n divided by I, and I multiply equals to 5. Uh, then we what gonna do is return simply the count. So what we're gonna basically do here is, like, if we take I equals to 5, I it will run for 30. When n divided by I is greater than equals to 1, yeah, that condition is true because it will give us 6. 30 divided by 5 will be 6, which is greater than equals to 5. The count will be added into that, because it will be counting the number of 5's in this, like 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Then I will again increase by 5. then it will become 5 into 5, 25. Then 30 divided by 25 is again greater than 1. So it will again come into the loop, and it will basically find the number of 25s in it, which is 1. So 6 plus 1 will give us 7. Or we can say 1, 2, 3, 4, 5, 6, 7. Then again it will become 125, and 30 divided by 125 will not be greater than 1. So it will come out of the loop and return the count. So what we are doing here is we are first counting number of 5s, then number of 25. Then if it's greater than 125, then we are going to do that for 125, 625. So that's how it works. I hope you understood it. Well, the cases I have already done that, uh, and it will be accepted. Thank you guys for investing time uh, in watching my video. Hope you like it.